Okay, so welcome back to the glorified education once again, and today we are going to see the topic further in the limits chapter. Basically, the chapter is combined limits, continuity, and differentiability. So we are going to see this chapter limit, continuity, and differentiability. And so let's start the questions. 21 question. The function is given to us. Let's see one by one. The function is given to us, and it is defined at x equal to pi, the value of, so there is single of only here, of f of pi, the value of f of pi, so that f of x is continuous at x equal to 1. That's all. So it means we have to find the value of limit. So if I find the value of limit here, limit x tends to pi 1 minus sin x plus cos x over 1 plus sin x plus cos x. So now we can see one thing here. If I put pi, so 1 minus 1, like minus 1 and pi is 0. So 0 by 0 form is formed. So we can do L'Hospital. So on applying L'Hospital, we'll be getting like limit x tends to pi. So for 1 it's 0. For sin x it will be basically minus cos x, I can say, like minus is already there. For cos x it is minus sin x, and then for sin x it is cos x, and then for cos x it is minus sin x. Now if you put pi, so 1 is becoming minus 1, so denominator is minus 1 and this is 0, and minus 1 and 1, that is plus 1, and that is 0. So the answer is coming at minus 1. So this is my answer for the option C. Basically the value of limit defines, like the continuity we all know. Continuity basically means the value of limit at the x tends to pi, that is LHL RHL should be equal to f of pi. So f of pi we have to find, so we have find with the help of limit basically. So this particular value will defines that f of pi is equal to minus 1. Let's move to the another question. So other question is, let us like consider the following functions. If f of x is given to 1 by x and second function is given like 2 by x, x square plus 2x plus 5, which of the following function is derivable? So for derivable, first thing is that we have to check continuity. We have to check continuity. So if I talk about the first function, first of all, let's talk about the first function only. So if I check the continuity of first function, if I put x equal to like LHL, if I talk about, or simply if I talk about limit x tends to 0, 1 by x, so it will giving me infinity. Now value of limit coming out to infinity means like we should know the value, we should know that value of limit and value of that is function should be finite. So here it is coming infinite. So it shows that the function is not continuous. But this function is not continuous. Not continuous. So it means if the function is not continuous, so it is not derivable also. Very fixed. So let me just now check for the second function. If I check for the second function, first of all, my responsibility is to check for the continuity. So if I check for continuity, let me check LHL first. If I check LHL, it will be like limit x tends to how much? 0, x square plus 2x plus 5. So it is nothing but if I solve it out, I will get 0 plus 0, 5. So LHL is 5. Now if I solve RHL for the second one, it will be 2x plus 5 and the limit will remains that x tends to 0. That is also coming out equal to 5. So LHL, RHL both are same, and even if I check the f of 0, so f of 0 is also 5. So I can say it is continuous. Now my aim is to check for the, that is what we call as derivability or differentiability. That's one of the same thing. So let's check it out and let's see. So if I check it out for this, like we have the 2x plus 5 for, let me just write it here, x greater than 0 and x square plus 2x plus 5 for less than 0. So this is what the function defined. Now if I check for the derivability, I can differentiate the function first. So I get 2 when x greater than 0, sorry, here we have x greater than 0 basically. So x greater than 0 and here we have x less than 0 basically. So for x less than 0, if I differentiate it, I will get 2x plus 2. Now if I just want to check, like this is a differentiation, f dash of x. Now if I want to check just left hand value at the 0, like my limit x tends to 0 positive f dash of x. If I check it out, so this will be 2 basically, because 2 is my answer, and that is my LHD is equal to 2. And if I check for RHD, that is limit x tends to 0 negative, sorry, this is basically RHD, sorry for this, because it's the right hand limit. And if I check for 0 negative, so I get f dash of x. So I'll be getting like 0 if I put, so I'll get 2 basically, that is equal to LHD. Now LHD, RHD both are coming finite and as well as equal, so my function is derivable. So I can say directly that my, just a minute, yes. So my, like I can say directly that the only 2 is derivable. 1 is not derivable, only 2 is derivable. Now let's move to the another question. So another question is saying that consider the function and we have to find the value of like a for which it is continuous x equal to -1 and x equal to 1. So see, if I check for -1, first of all, let me check for -1 here and here I have -1. So like if I check for like -1 or if I check for 1, from both I can find the value of a. And since we have 4 options, like option 1, 2, 3 and 4, and there is some value. So it means like if we check from either of the following, we will get the answer. Like let's say if I check from the first one, like for x equal to 1, if I check it out. So for x equal to 1, if I check the LHL, so LHL is nothing but left hand limit will be this one. A times, I am putting directly all the things, not wasting the time here. A times of, like if I put -1, -2, that is equal to -a, -2. And if I solve for the RHL, I'm again putting directly value that is equal to -1. Okay. So -a, -2 equal to -1, that is equal to 2 minus 1 and this, so a equal to -1 coming out. So my a option is correct, that is a equal to -1. And if you check for the if you check for the limit for the this also, let me just draw it here. This 1 also, if you check the limit for 1 also, you will get the same answer. That is about this question. And let's move to the another question. So we have a function again. So here the things are little different. Let me check it out. X square upon a, or it might be like 0 to 1 we have, and then a we have, then this we have. So I need to check that what is the first function. So just make a hold on here. Let me just check what is the first function basically. Just make a hold on. Okay, fine. So it is nothing but x square by a only. So let me move. So it is x square by a basically. If I write it properly, it is x power 2 upon a. This is my function. Now if I see like the most suitable value of a and b, so let's check it out. So I can be check at 1 and I can check at √2. So these are the basic values for which I can check the LHL and RHL. So basically if I check for the LHL of at 1, like for x equal to 1, if I find LHL, so LHL is nothing but that is 1 if I put, so x 1 upon a, like basically 1 upon a, fine. And for RHL if I check the things, like it is basically RHL is equal to a basically. So if I compare 1 by a is equal to a, I get a square equal to 1. So basically a equal to plus minus 1. So we have two values of a, plus 1 and minus 1. So we have to check like which of the following will give me the b corresponding value. That will be our basic satisfactory value. So we have to check this. So a equal to plus minus 1 for a time being. Now let's move towards the b value. So for the b value, let's check it out. Let me solve it here now. Just a minute. Yes. So if I just put for √2, so like LHL will be like if I check for x equal to √2, my let me erase this part. So if I check for x equal to √2, this is x equal to √2. If I check, my LHL will be actually equal to a, and if I check for RHL, I put like √2 square, that is 2. So basically I get 2b square minus 4b over 2. That is equal to b square minus 2b is equal to a basically. Now a is plus minus 1. So I have to solve for two cases. Like let's solve that. Let me take in the next page. So we get b square minus 2b is equal to a. Now my a is plus 1 and minus 1. So I am going to solve one by one. B square minus 2b is equal to, suppose 1 first. So b square minus 2a minus 1 equal to 0. So that's a quadratic. Let's see. So 2 plus minus root of b square, that is 4 minus 4 into a. So that's fine, upon 2, that is 2 plus minus 2 √2 over 2. That's what I get, 1 plus minus √2. So this is value of b basically. Now this is like, if I can say corresponding to 1 we have this. So corresponding to 1 we have 1 plus √2, and corresponding to 1 we have 1 minus √2. So these are the two options as of now which can satisfy. So corresponding to 1, these are the functions. And if I check for minus 1 basically, that is b square minus 2a equal to minus 1. So I get b square minus 2a plus 1 equal to 0. So b minus 1 whole square equal to 0. So b equal to 1 basically. So for minus 1 I am getting 1. So for minus 1 I am getting 1. So let's see. So minus 1 I am getting 1. So this is like basically the option number C. because for -1 I'm not getting this 1 plus root 2. Okay, for 1 I am getting 1 plus root 2 and 1 minus root 2, so that's not given in the option, so I will not be considering that. So my answer will be a equal to -1 and b equal to 1. Now let's see the another question. So it is set of the all point of differentiability of the function. So if I see the function, first of all, if I see the function x square sine of 1 by x, so it's basically the function is changing at x equal to 0. And even if I see that this particular denominator, that's x equal to 0, is causing some violation or not. So it can cause some violation, so that I have to check. Otherwise, it is like x square is continuous all the way, sine of 1 by x is continuous all the way. So basically going to like continuous and continuous will definitely going to give you continuous. So that's not an issue. But the main thing and differentiable also. So the main thing which we have to check is that we have to check the derivability at x equal to 0. If it is derivable at x equal to 0, it's very obvious that my function is, again I can say, just a minute, yes. So my function is, if the function is derivable at x equal to 0, I can say the function is derivable at all the points belonging -infinity to +infinity. So let's see. So if I see for this, first of all, if I see LHD, sorry for this. If I see for LHD, or let me just check the limit directly, rather of checking LHD and all. Or otherwise it's my choice basically. So LHD is nothing but limit, if I apply f of, like this is basically x 0 minus, so I apply that as f of 0 plus h minus f of 0 over minus h. And if I check for the RHD, it is limit x tends to 0 positive f of 0 plus h minus f of 0 upon h. So first of all, let's calculate the LHD. So if I calculate the LHD, my LHD comes out to be, if I put 0 minus, like let me just check 0. So it will be x square sine of 1 by x. So minus f of 0. So at 0, like sine infinity we get, sine infinity is a value between -1 to 1. That's a finite value. So finite into 0 will get, that will going to be 0 over minus h. So this h and h cancel out and we get sine of 1 by h over -1 by h. Okay, fine. So this is my LHD basically, LHD. So if I solve this one and if I put my, or rather don't do this like this, because basically it is a finite value. So if I put h equal to 0, see I left with what? I left with h into sine 1 by h. So if I put, and also -1 here. So if I put h equal to 0, so 0 into a finite value, because sine of infinity is basically a finite value that is between -1 to 1. So I will get 0. Now if I check for RHD, let's check for the RHD also. So it will be h square sine of 1 by h. If I put h directly, minus f of 0. So f of 0 will be 0 basically over h. So if I solve this out, I will get, let me just make it small. So it is h basically. So I cut it. So it becomes h into sine 1 by h. And now if I put h 0, so I will get 0 again. So LHD and RHD both are coming equal to be 0. That's I can say that at x equal to 0, my function is differentiable. So at all the point between -infinity to infinity, my function is differentiable. So I can say simply that the -infinity to +infinity. So this is my answer, and this is about this 5 question. The next question we are going to see in the next class. Till then, please watch this video carefully and learn it, and you can do like also, comment also, please. Like I have seen like you are watching the videos and liking the video also, but you are not commenting. Please comment so that I can be very motivated to make more such video. So thank you so much.